number 7. This one's an interesting question. Really, the brute force way of doing this is a couple things that you'll need to sort of figure out. Is one, you need to find the displacement during the first 3 seconds. So we'll call this delta D1. And then you've got to find so this is the first 3 seconds, and then the other one is the next 3 seconds. So the next 3 seconds. So 3 seconds to 6 seconds, and this one's 0 seconds to 3 seconds. So you find the D, and so you have the initial velocities at rest, so Vi is equal to 0. Delta T is 3 seconds, and the acceleration is 6 meters per second squared. So it's going to be Vi delta T plus 1/2 squared. But since Vi is 0, that just sort of falls out, and I get that first displacement is just 1/2 delta T squared. And so you find out, you plug in the values, and you get a number. Well, let's put in the numbers actually. So I'm going to have 1/2 times 6 meters per second squared times the first 3 seconds squared. This comes out to 27 meters. So that's for the first one. So that's our first displacement. The next 3 seconds, though, the problem is we've got an initial velocity. So first, let's find the final velocity. The initial velocity, this initial velocity for this next 3 seconds is equal to the final velocity from the first 3 seconds. So that's going to be the initial velocity for the first 3 seconds plus that acceleration times the time. So again, this is 0. So that's nice and simple. And then we can say that this is 6 meters per second squared times 3 seconds. So we get an initial speed of 18 meters per second. Now we can plug this in and we can say that the delta D2, the second one, is our initial velocity times our new 3 second interval plus 1/2 delta T squared. But here's an interesting thing. This 1/2 T squared was already 27 meters. So, and I want to know, I'm going to subtract that because I want to know how much farther it went in the second period. So if I want a second 3 second interval, I'm actually going to subtract the 27 meters eventually, but I know that that's 27 meters. So I'm going to have 18 meters per second times 3 seconds. Let's just put it in for, so 1/2 times the 6 meters per second squared times 3 seconds all squared, but I know that's going to be 27 meters. So 18 times 3 would be 54 meters plus the 27 meters, which is 81 meters. So the difference is this 54 meters. So it went 54 meters farther in the second 3 seconds. That's when you can actually do it algebraically, just for fun. I know this, so I've got this relationship with my delta D1 is equal to 1/2 A delta T squared, and my delta D2 is going to be V, the initial velocity for 2, delta T plus 1/2 A delta T squared. Notice that the 1/2 A delta T squared again is common to both. But here's the interesting thing, that my Vi2 is equal to A delta T. So A delta T times delta T is just A delta T squared plus 1/2 A delta T squared. So if I subtract these two, if I want to find how much longer, so delta D2 minus delta D1 is equal to a delta t squared plus 1/2 a delta t squared minus 1/2 a delta t squared. So those disappear. So I end up with a delta t squared. So now I can plug in this number. I've got 6 meters per second squared. Multiply that by 3 seconds, and all squared.